So welcome all for today's lecture. Today we will study about ARM instruction execution and implementation, which is a very important topic in embedded systems. Uh, Set computer principles, key features of ARM, which loads store architectures, only load and store instruction access memory, which it has large registers set, which reduces memory access and improves speed. It has low power consumptions. It is ideal for battery operated devices, high performance per watt. The advantages of reduced instruction set computer principles. The first one is the instructions are very simple and fixed length. Most instructions execute in a single clock cycles. Operations are register based. Supports pipelined execution. Because of these features, ARM's processors are fast, efficient, and power-aware, making them perfect for embedded systems. Next, we are going to discuss on the topic ARM instruction set and classifications. ARM instruction set is classified into different groups based on the functionality. The first one is the data processing instructions. The data processing instructions used to handle the arithmetic as well as logical operations like addition, subtraction, and or logics. These instructions mainly performed with the help of arithmetic and logical unit. The next one is load and store instructions. The LDR, load data from memory to register. STR, store data from register to memory. We have to remember one thing. ARM follows a pure load store model. The next one is branching instructions. The branch stands for branch and BLS stands for branch with the link, used for loops, function calls, and control flow. Multiply instructions used for fast arithmetic operation. Software interrupt instructions used to call operating system services. Next, we are going to discuss on instructions execution cycle. So ARM processors execute instructions using a pipelining mechanism. So generally, what is meant by pipelining? The pipelining is a concept which splits up the huge task into equal time interval tasks, and it is carried out continuously throughout the process. The pipelining divides instruction execution into 5 stages. The first one is instruction fetch, the next one is instruction decode, the third one is instruction execute, the fourth one is memory access, the fifth one is write back. Because of pipelining, multiple instructions are processed simultaneously at each stage. This significantly increases throughput and performance of the processors. Next, we are going to discuss on the topic instruction fetch and decode stages. Generally, the instructions are fetched from the memory into the processor and it performs some operations and it will again use the results. First, we will discuss about the instruction fetch. The instruction is fetched from the memory. The program counter holds the current instruction address. The PC is automatically incremented to the next address when we load the data. The next instruction is prefetched into the programming counter for the smoother operations. The next one is instructions decode. First, the instruction opcode is decoded. Source and destination registers are identified by the processors. The control signals are generated. Conditional field is checked using the status flags. This stage decides whether the instruction should be executed or not. Next, we'll discuss on execute, memory access, and write back stages. Now, let us see the remaining stages one by one. Execute stage. The ALU performs arithmetic and logical operations like addition, subtraction, and or not everything. It is performed in this execution stages. Shifter performs the shifting and rotate operation. We have done right shift or left shift, rotational, everything. The branch target address is calculated. Conditional flags are updated. The next one is the memory access MEM, which used to load instruction and read the data from the memory, and it will stores the instruction write data into the memory. Data processing instructions skip these stages. Write back stage, the execution once the execution is done, the execution results are written back to the registers. The program counter is updated for branching instructions. After this stage, instruction execution is completed. Next, we are going to discuss ARM conditional execution and instruction format. One unique and powerful feature of ARM architecture is conditional execution. So what is meant by conditional execution? The conditional execution, every ARM instruction can be executed conditionally. So conditions are checked using CPSR flags. The N for negative, Z for zero, C for carry, and V for overflow. This feature reduces the number of branching instructions, minimizes pipeline stalls, improves performance. Next one is ARM instruction format. The ARM instruction consists of conditional field, opcode, operand field, destination register, operational shift operations. The next one is we are going to discuss on instruction implementation and advantages. ARM instructions are implemented using data path and control unit. Implementation highlights. It is hardwired logic, efficient coordination between ALU, shift registers and registers. Advantages. High instruction throughput, reduced power consumption, efficient silicon area usage, excellent performance for embedded and mobile systems. Pipeline execution plays a major role in achieving these benefits. The next one we'll discuss on pipeline hazards. Pipeline execution may face hazards. Types of pipeline hazards are structural hazards, avoided using hardware duplication, data hazards, handled using data forwarding, conditional control hazards, minimized using conditional execution. ARM architecture is designed to reduce these hazards effectively. The next one is applications and conclusions. If you take the applications of ARM processors, which is mainly used in smartphones and tablets, embedded control systems, IoT devices, and automotive electronics. If you come into the conclusion part, generally ARM instruction execution and implementation focus on simplicity, efficiency, and low power consumptions. The pipelined execution and conditional instruction supports make ARM processors highly suitable for embedded systems. Thank you.